Hey, welcome back to Mr. PL's Precal. This is Unit 5, Topic 2, Lesson number 7. We are solving system of equations using matrices. We're going to first start off with a couple of questions which are similar to what you've done in Algebra 1 when solving a system of equations. You can use substitution method. Well, in this case, we already know the answer is 3 and negative 4, 3 for x. So in rectangular form, this is always x, this is always y, x and y. So if I want to solve, so I want to find the solution of a system of equations, or solutions is what I wrote. I could just simplify, I could just plug these into here. I could substitute them in for x and y. So 2 times 3 minus y, which is negative 4, should equal 10. And the other one should also be true. So 3 times 3 plus 2 times negative 4 should equal 1. So now it's just a matter of simplifying. This becomes plus 4. 6 plus 4 does equal 10. And this is 9 plus negative 8 equals 1, and it does. Checks out as well. All right, so these two, this value of x and this value of y, are the only two values that are going to make both of these equations true. If you were just given one equation, there could be an infinite amount of answers. It's going to be a linear graph, and anything on that linear line is an answer, that x and that y. But when you have two equations, then it's going to limit your answers. In this case, there's only one answer, this x and this y. All right, so back in Algebra 1, you were given equations like this, and you're shown a couple of different methods for doing this. And I'll be quite honest, I would not use substitution method for this. I think the easier way of doing this question would use the elimination method. I would eliminate the y's by multiplying everything in this line by 2. So that makes this 4x, that makes this minus 2y, that makes this 20. And then now I've just replaced this line with this by multiplying everything by 2 so that I can take this line and this line and add them together. 4x's plus 3 more x's makes 7x's. Negative 2y plus 2y makes no y's. Once again, this is called the elimination method. I just eliminated one of the two variables. That was the whole point. That's the reason why I multiplied this line by 2. And then 20 plus 1 makes 21. Obviously, divide both sides by 7, so that x is 3. And then once I have that value, then I can substitute that back in. 3 times 3 plus 2 times something equals 1. This is 9. And subtract 9 from both sides, you get negative 8. So this 4 means y must be negative 4. Now, I'm going to clear that out. 3 and negative 4, and now I'm going to solve it the other way, which is using the substitution method. I should get the exact same answer. I'm going to solve this for x. I'm going to say 2x minus y equals 10. I'm going to solve for x, so 2x equals, so if I add y to both sides, I got y plus 10, and then if I divide both sides by 2, so that x equals, well, 1/2 y, or y plus 10 over 2. So that will be y over 2 plus 5. Now what I'm going to do is I'm going to take this, I'm going to substitute it right there. So 3 times that expression, which I'm just going to leave it y plus 10 over 2. I think that's going to be an easier way of doing this. Plus 2 times y equals 1. Alright, so now I've got all y's, no x's, so I've kind of eliminated one of the variables in a roundabout way. So 3y plus 30 over 2 plus 2y equals 1. So this then gets divided, so 3/2 y plus 15 plus 2y equals 1, and then add these two together, so 1/2, 2, so that makes 3/2, which makes what, 7/2 y equals negative 14, and then if I divide both sides by 7/2, which is the same as multiplying by 2 over 7 times 2 over 7, so that y equals, alright, so negative 14 times negative 2 is 28. 28 divided by 7 is 4. Okay, that was a little bit messy a way of doing it, but you'll see that we did get the exact same answer. And if I take this and I plug it back in, yeah, of course, I'm going to get the exact same answer for x as well. Alright, I'm going to leave it there. So let's take a look at how to solve this question. That was a lot of work, and that's kind of the point here. I know I'm already 4.5 minutes into the video, is that there must be an easier way of doing it, and there is. I'm going to use a matrice in order to solve it. So the way I'm going to do that is I'm going to take 3. In fact, that was just the last question I just did was a system of 2 equations. This is a system of 3 equations. So there's more to this. You would think it would take longer because it has more equations in it. But actually, when you use a matrix, it's going to be a lot easier. So the first thing I'm going to do is I'm going to create what's called an augmented matrix, which means I'm going to take all the coefficients of all of these, and I'm going to make it into, so this is a coefficient of 1x, this is negative 2y, this is 1z, and the answer is 7. So you might see people make it augmented look like this. And I'm actually going to separate this into 2 different matrices, which you'll see in a second. So then for the second line, so there's 1y, negative 2z's. Oh, wait, I missed the x. Okay, so let me delete that out. Got to do it in the same order every time. So this has got to be the x, this is the y, this is the z. And then this is the x, this is the y, this is the z, which you'll see in a second going across. So there is no x, there's a 1y, and there's negative 2z. There's no x's, no y's, and 1z. This total was negative 7, and this was 3. And there you go. There's your augmented matrix. Now, I'm actually going to separate this into matrix A is right here. And then it's going to get multiplied by x, y, z. And that's going to give you your answer, which is going to be matrix B, which is right there. Now, if you watched the last video, you saw how to solve this by basically multiplying this by the inverse of this. So if you find the inverse of this, and I found this by just putting it in the graphing calculator. I just put this in the graphing calculator, press A inverse, and then press enter, and it gives me this. And then if I multiply this by this right here, or a solution, it's going to give me my x, y, z. So the inverse of A times matrix B equals, there's your 3 answers. X is 2, y is negative 1, and z is 3. We kind of knew z was 3 to begin with, though. And there we go. That's a lot less work than what I just did on the last slide. Okay, so one more, and then I'll show you myself doing one. So I know these take quite a bit of time, so I kind of left the work here so you can see some examples. Otherwise, I wouldn't get to do much. All right, so first thing I did was I wrote, this is the x, this is the y, this is the z. So there's 1x, negative 3 is the y, 1z. And then there's no x's here, 2 y's, 3 z's. And then no x, no y, and there's 1z. And then, of course, 0, 1, negative 2 are the constants. Those are the numbers that has to be set up just like this for this to work. So then you're going to multiply this by x, y, and z. So this times this will equal this. So once again, how do I solve for x, y, and z? By taking the inverse of A, just put this in the calculator, press A inverse, and it's going to give you these numbers, and multiply it by matrix B. Once again, you can do this all in the calculator. So once you have this entered in the calculator, then you enter this in the calculator, and you multiply these two by each other. Keep in mind that the order does matter for multiplication, so make sure you're doing inverse times b and not the other way around. And then voila, you have your answers. And if you want to check them, go ahead, put these numbers into any one of these lines, and I guarantee it's going to work. All right, so one more, and I am going to have to pause because I'm going to do a lot of this into the calculator, and I don't want you to have to wait to see me do that. So let's say matrix A is... So the first line is going to be 3, x, y, and z. So negative 1 and 2. And then the second line is going to be 0, 1y, and 3z. And then the last line is going to be 0 x's, 0 y's, and 2 z's. And then matrix B is going to be negative 2, 3, and 4. All right, so the next thing I'm going to do is I'm going to enter matrix A into my graphing calculator, and I'm going to find the inverse. This is where I'm going to pause. All right, so that you can see what I have done, here it is. All right, so that you can see what I've done. All I've done so far is I've entered matrix A, which is right here, and then I'm going to second mode, and then that's going to bring me back to the normal screen. I'm going to go back to matrix, which is second matrix, and then I have, it says right there 3 by 3, so I'm going to press enter for A, then press the inverse button, press enter, and it's going to give me the matrice, which looks like A inverse is going to be 1/3, 0, 0, and then This is also 1/3, 1, 0. And then the last line, negative 0.83. And of course, it's going to do this basically all itself. So negative 1.5 and 0.5. Okay, so then all I have to do is multiply this matrix by B, and that's going to give me my answer. So let me clear that out. Second matrix, A, make sure I press the inverse button, and then I need to multiply that by B, which I still need to enter. All right, so here's what it looks like so far on my screen, like that. And then I'm just going to press enter, and then it's going to give me my answer, which is a 3x1 matrix, which happens to be -3, -3, and 2. So that's your answer. So X is -3, Y is -3, and Z is 2. And those are your answers that go in right there. And that would be it. So that's pretty much the steps. I'm going to go ahead and stop right there. Please give it a like if I helped you learn how to solve a system of equations using a matrice. Have a wonderful day. Thanks for watching.